Welcome back to Reimagine. I am Yonah Hochhauser, and today I'm glad to be joined by Emre Tekisalp, VP of Business Development and Operations at O1 Labs. Emre, thanks so much for joining us.
Yeah, thanks for having me.
Well, first off, you want to tell our guests a little bit about kind of who you are and how you got into blockchain?
Absolutely. So as you said, I work on biz dev and operations here at O1 Labs. We incubate the Mina protocol, which I'm sure we'll dive into later. I've been with O1 Labs for about a year and a half now. Before that, I was at Coinbase, which I suspect many of the audience will know, one of the largest exchanges, where I was also working on business development. One of the earlier employees there. So worked on a bunch of things from, because it's custody product to wallet product, USDC, certain M&A transactions. So a bunch of stuff, as you might imagine, at a fast growing company. Before that, I come from a more traditional tech background. I spent most of my time at Intel, both product and biz dev again. So I guess that was also part of what got me interested in this space, where one of my last projects there was working on a what you call, like an NFC payments platform. So I think the Apple Watch, how you tap and pay. And that allowed me to really just realize how antiquated the whole system, the existing system is, and just get really frustrated with it. And as I was going off to grad school, I was like, okay, might as well learn if there's a new thing coming up that, might just be a bit smarter and more digitally native. And that naturally got me into crypto. So yeah, it's been a wild ride since, let's see, I started, I guess, dabbling in 2015. So about 5 years or so, which is, I guess, 50 years in crypto. So yeah, still hanging
Very
in there.
nice. That's pretty much the entire lifespan. I mean, depending how where you look at it, it's a real OG. It's always nice to speak to someone from the beginning. Now, we'll get into. There's a couple of things I want to talk about. From your background, but let's start off with you can't ignore the giant Mina in the corner. You did mention that at O1 Labs you guys are developing and working on the Mina protocol. You want to give a little go in a little depth about what is the Mina protocol?
Yeah, of course. So Mina is a new blockchain. It's the world's lightest blockchain, and it's powered by its participants, much like many other blockchains. But one of the key issues that we're solving for is the fact that as blockchains get more powerful, less and less participants can run it, right? Many audience will be familiar with this in the form of the Bitcoin scaling debate, where folks wanted to increase block size, some didn't, and the ones that didn't, which obviously is now still the actual Bitcoin, didn't want to do it because of centralization concerns. Because the more increasing the block size or the size of the entire blockchain means that you basically put more resource demands onto the nodes on the network, which makes it more costly, which decreases the number of nodes that might be able to run the said node software. And that decreases decentralization, which is not something we want in a public blockchain. We want it to be growing, right, in terms of decentralization. So what we do at Mina is to use the power of zero knowledge proofs, which is this specific category of cryptography, which got really hot and popular with blockchains, starting with Zcash and now with many other blockchains. And we are the first project to use what's called recursive zero knowledge proofs in production. This is basically what happens if you take a proof of a proof of a proof, and recursive goes on. What happens in Mina is that you get a fixed size blockchain. So Mina has a 22 kilobyte proof, which is always fixed in size, no matter how long the blockchain has been around for, or how big or how powerful it gets. So if you connect the dots, this solves for that issue that we just described, where we want these blockchains to get more powerful, do more transactions. But at the same time, you don't lose any decentralization because the blockchain is fixed size. It never gets more expensive to run the blockchain. So that's how we kind of set forward on this path. And one other key benefit of Mina is using the same zero knowledge proofs. We're also able to bring some unique benefits to applications running on Mina. And these mostly have to do with data privacy and trustless access. So what I mean with that is, any blockchain, or let's say Ethereum, just since we're comparing or talking about applications, whatever you put on the blockchain is public, right, forever. That's obviously, for some use cases, it might be useful, but for most, you don't want your personal data to be there public forever. And what what one can do is to prove facts about their data to an application, but don't share the data itself, so that your data doesn't stay always on the blockchain. And you can also do this in a trustless way, which we can dig into a bit further later, but users can get data from the rest of the internet, so what one might call off-chain, without having to resort to oracles. So that's another powerful nature, because if we had to resort to oracles, then the data privacy goes away again, because it's the oracle who's relaying your data, so they would then have access to your data. So long story short, we're a very zero knowledge proof centric project. We pride ourselves in being one of the best teams in that space. And we use the technology to solve a bunch of important problems in the space. And we're actually really getting really close to launching. So hope to have our mainnet out in a few months. And we've been doing a lot of preparation for that. So yeah, we can talk about that as well.
Wow, 22 kilobyte. That's quite a small. For those who don't know, if you want to sync a Bitcoin blockchain, it's hundreds of gigabytes at this point. Now I tried syncing once and I waited a week and I gave up. So that is a big deal for those who a lot of people who interact with blockchain are just buying coins, and they don't run nodes. They don't realize this issue of ever growing and ever scaling blockchains. And 22 gigabytes, that's tiny. That's like, you could actually just be syncing it on your smartphone, not go over your data cap. But the question being, I understand using zero knowledge proofs and recursive proofs to be able to verify, that everything is correct, but doesn't still the entire blockchain have to be stored somewhere?
Yeah. So this is actually a common confusion about how Mina operates, because at once you're like, oh my God, 22 kilobytes, it's all compressed, it's amazing. But then you're like, where's the data, right? Mm-hmm. So, to dig into that, what's easy is to actually flip the argument in its head, to say, so Mina is actually, if you were to strip away all this zero knowledge proof stuff, it's very similar to other blockchains. In fact, just to give an example, we use our own derivation of Cardano's consensus mechanism called Ouroboros. And there's many other common elements to other blockchains. And there is, what in Ethereum is called like an archive node, where if you were to store the entire history in a database to, query historical transaction information, etc., we actually have a node for that, so you can do that, and block explorers do that. But the benefit of Mina compared to others is that, let's say in Ethereum or other blockchains, in order to connect to the network in what's called a full node capacity, right, which is basically that you don't have to trust other people, which is a key element of blockchains, you have to download basically the entire chain, which is hundreds of gigabytes, if not terabytes, I guess, at this point. With Mina, however, you can do the same thing with that 22 kilobyte piece of data. So you don't have to store or download the entire chain. You can do it if you want, if you have a use for it. But the benefit is you have the option of just, being able to be a full node in the network with just 22 kilobytes of data.
Mm-hmm. Is there an incentive for someone to actually host that the entire history of the blockchain on their node? Do they get rewarded for every historical query or something like that? Or is this something that, you just hope that you guys will host yourselves and every node can always just check, and verify it because they could just verify it with using the 22 kilobytes?
Yeah, great question. We don't have any native incentivization mechanism for running archive nodes. It is what you said, right? It's that certain folks, such as us, or the Mina Foundation, will have just intrinsic reasons for storing archive nodes and providing services, and others will have economic benefits, such as, archive node services on Ethereum, for example. They charge users for, to query historical transactions. So as use cases pick up, as Mina becomes more commonly used, we expect those to spring up. But until then, if it's required, we will be providing those services, and there will be enough alternatives.
Mm-hmm. Well, and now that like this kind of this idea, I mean, I wonder, you'd probably know better than me. This kind of system, I feel like, could be used in both private blockchains and in different applications. This idea that there's that a one centralized figure, one centralized organization kind of hosts the entire blockchain, has all that storage requirement and all that on them, but then because there's using zero knowledge proofs and recursive proofs, that everyone is able to so easily and quickly verify that centralized blockchain. I feel like this could be used in other applications. Let's say a private blockchain, a bank has their own blockchain. If they use this type of system, where pretty much anyone could come in and verify it, using their smartphone or something like that, I do feel like this opens up a whole world of opportunity. I know that isn't your guys' intention. That wasn't your target, I'm sure, to do it this way. But along the way, have you guys learned some lessons and figured, hey, maybe we could actually extrapolate this idea in other areas? Like you guys were aiming for that light blockchain, but this is kind of cool, that you happen to find this whole other area.
Interesting. Yeah, I need to think a bit more about that. But so I'll tell you why we didn't think of it in this way. Maybe we're missing something, and I'll give another example of what we kind of came across along the way. The reason we didn't think of actually, high level, everyone has asked us the question like, this is cool, why can't you apply to other blockchains, right? Or why can't you do this just Bitcoin, right? Because those are just more popular and existing blockchains. The trick is, there's a lot of design choices basically, and it's not just like one single major choice or something. It's just like every small single piece of design in the entire architecture of the blockchain has been optimized to enable this. So whether it's like the cryptographic hash functions that you use, or how consensus treats messages, or how, for example, we have an entirely separate set of economic actors in the Mina blockchain called Snark Workers, or Snark producers, in addition to block producers, whose job is to produce these Snark proofs, in effect, to compress the blockchain. So, like if you don't include those in the design of the chain from the get-go, how do you make sure that they're a part of the economy of the chain? In Mina, they have their own marketplace. We call it the Snarketplace, where they buy and sell proofs. So like there's a whole lot going on. So as exciting as it sounds to just say, wow, this is really cool, let's just put it on every other chain. Unfortunately, it's not that simple. And this is a lesson that we've learned over, I guess, 3 years now at this point, where there's a lot of, small things that come up that you got to fix and optimize. What we have learned along the way, though, is, again, something I mentioned, which is about how you can apply some of this magic to applications running on a chain like this, right? Or using zero knowledge proofs. So much so that we, at this point, gave apps running on Mina their own names. We call them snaps, again, after Snark powered applications. There's a lot of puns.
Yeah, you guys are really leaning into that Snark branding.
Yeah. Unfortunately, I can't, claim credit, but it's mostly to our CTO, Isaac. He's the master of puns. But as I was mentioning, using the same technology to empower these applications to be able to do much more mainstream, widespread use cases. Because if we're honest, like all the DeFi stuff and all the other application lines here are great, but it's still just rich crypto people that are playing around with them, right? Unfortunately, not a lot of mainstream people beyond Bitcoin have had a chance or been able to benefit from these, because they can't, right? They have to over collateralize stuff, or they have to, like have hundreds of dollars to pay for gas or whatever. And we can't claim that we're going to solve all these problems magically, but
Yeah.
this issue of data privacy and being able to use data from other places in the web, which we all have, are important in our minds. So we figured out ways to solve that, and pretty excited with what we're going to be able to bring to the market.
Mm-hmm. Well, so you mentioned, well, let's break through all the snarks now. So you mentioned that within this Mina ecosystem there are snark workers. You said.
Yeah.
What's the role? What's the role of the snark worker?
So we also call them snark producers, which might
Snark
be
producers.
easier to
Okay.
compare.
Okay.
Because in a traditional blockchain, there's block producers, right? Whether they're called miners in proof of work or validators in proof of stake, what they do is to produce blocks. In addition, we have these snark producers whose job is to create snark proofs. So what they, without getting into too much detail, because unfortunately without a whiteboard, this gets really complicated really quick, is so these folks don't take part in the actual consensus mechanism. That's for the block producers. But what these guys do is basically snark every transaction, such that if you remember, like we have this recursive system where basically in every block, you have the proofs of every transactions. They get snarked into like another snark, and along with this is why I said it's going to get
we're good.
Snark of the block, they get snarked together again, such that they then feed into what we call this canonical snark of the entire chain. So there's a bit of recursion going up, from all the way from transaction level to the top of the blockchain, I guess. So these snark workers are doing all that work. And basically we see snark work as, as cool or sexy as it might sound, it is a commodity work. It's basically kind of like mining, but I don't want to go down too much that path because then it get confusing, because mining does consensus, snark workers don't. Whomever has the most compute power, they look at the blockchain, they take unsnarked transactions, they snark them, and then they sell these snark proofs actually to the block producers, because the block producers need to make sure that all the transactions in the blocks they're going to produce are snarked. So this is basically like, people that are really good at or have ample compute power, they tap into the network, they make a couple bucks or hundreds of bucks or whatever, I don't know how much power they have, and they basically provide this service to the chain, which in effect does the job of compressing the chain, right? From what might be hundreds of gigabytes if it were a traditional chain to all the way down to 22 kilobytes.
And could the snark producer also be the block producer? I mean, if they already have all this computing power, they could both produce the snarks and then immediately, and then instead of just selling it to themselves, essentially using it themselves to then produce the block.
Yeah, they could sell it to themselves, but so what we actually saw in a few testnets ago, it's actually been a while, is we ran this challenge where we're like, okay, like the most number of blocks produced versus the most number of snarks produced, not versus, but like both in parallel. And when we looked at the top three, is the ones that I remember, I think there was one shared user in the top three of both. And what they did was, whenever they were, because in Mina, the way our consensus works, in every epoch, which is how like time is divided up to sections in stake chains, at the start of every epoch, when you're required to produce a block, because epochs are then divided down to slots, so you know which slot you won based on your stake. So a smart, for lack of a better word, block producer can do is look at when they're expected to produce a block, turn off their block producer when they're not expected to be online, and then when they're offline, block production wise, they run snark producers. So they're always using and leveraging their compute capacity.
They can't do it simultaneously. It's not allowed.
They can, but the complexity is that when they're producing a block, they also have to produce a block or a snark for the block, which is separate than the otherwise snarking going on.
Okay.
So they prefer to focus their snark capacity to that snark, because
Mhm.
If they are not able to do it in time, which snarking takes some time still, then they miss the chance to produce that block, and they lose the money that they would otherwise get. So there's some optimization that can happen there. Maybe others will figure out a way where they don't have to turn on and off the two separate things. But yeah, so people can do it at the same time. There's a lot of very at this point experience because we've been running our test nets for over a year and a half, believe it or not. So some experienced users that have learned a lot of lessons along the way. And yeah, if those interested, definitely hop onto our Discord
Yeah.
server, and there's a lot of folks eager to help.
Yeah, that's the crazy thing about this, this world that, this cryptosphere, this blockchain. It's the technology is so new, and then as you're building the technology, like there's just whole new economic incentive models that are just that you don't even think of, that just people, that just markets figure themselves out. And like you said, there are these block producers who are also producing snarks in ways that you never really thought of. And it's a fun dynamic. It's a really fun dynamic. I think this confluence of technology and economics and finance that we're seeing in this blockchain world, that I love, and it gets me excited. And I know a lot
Yeah.
of people do too. I mean, for the most part, I think the people coming into the blockchain and crypto space are more capitalistic and more market driven, and so now that does get me excited. Now, besides the economic incentives, you did mention something interesting, that you guys don't actually require oracles, which is definitely, oracles have really jumped to the forefront recently with the explosion of DeFi and the need to bring off-chain data on-chain. How does that work that you guys don't require oracles?
Yeah, so this is very cool. So let's maybe define first what an oracle does, right? You know, they're connected to various blockchain networks. Let's just say Ethereum for the sake of simplicity. And when Ethereum users want to use certain data from the off-chain world, they basically go out and get to that website and grab that data and put it on the chain, right? Let's just say again, it's pricing data for Bitcoin USD trade, right? Which is a common example. Um, but if we think of non-common examples, such as, okay, like what's this user's credit score, or what's this user's, what do they post on social media, or how much likes did they get? Then there's two problems. One of them is that if it's a private data, then basically that Oracle has to see that data, right, to carry it over to the chain where the privacy breaks up. Or if it's these random pieces of data, or like these long tail pieces of data, right, such as what's a random user's, how many likes did the random user get in this random tweet that they posted, right? Just a stupid example. Who knows, maybe someone will figure something out with that. But it's just like they're never going to be able to, well, let's never say never, but like they won't be easily able to figure out how to get that long tail of information. So there's these issues with oracles. What we have figured out, and we're building this as we speak, but is to use again the magic of snarks. By the way, snark is a specific zero knowledge proof algorithm.
You're not calling it Snagic?
We hadn't come up with that one yet.
Tell Isaac.
Oh,
Tell Isaac. I thought
yeah,
of
yeah,
it.
yeah. Thank you for that. I guess I'm the one who's bad at this. Others, other people are good at it, such as yourself. So we use this magic to basically. So here's one thing we discovered. Most of the required pieces already exist in the web, as it is, which is in the form of HTTPS signatures. So if you think of any, let's assume you're going onto a website, the data that you're getting is already encrypted and signed by the transmitter or the hosting website, right? So let's say again, if it's your credit score on a website, or if it's the social media stuff, they're all signed by Twitter or by Credit Karma, which is a popular provider of said data in the US. So basically, you're getting these pieces of data, right, which are signed, and which you can, if you were to recalculate, what those signatures were saying and be able to put that on chain, you could easily say, well, look, this data I actually got from Twitter or Credit Karma, and this is what the data is, and here is it on the chain. The challenge is, again, an oracle right now has to do it. But with zero knowledge proofs or Snagic, what we're able to do is run that computation inside of a Snark and have a proof associated with it, which says, if you were to run this computation yourself, you would verify that this data came from Twitter or Credit Karma or whatever. So this completely removes the need for an oracle and basically gives you both the privacy that you need, because any user can do this locally on their computer and soon on their smartphone. It's still, well, we haven't really tried it out. Now smartphones are getting more powerful than PCs, but so we've tried it on a PC and it works in a few seconds. And any user is able to do this. And also you can do this for random pieces of data, right? It doesn't care. It's just a piece of software, whether it's like a random like count on a tweet somewhere, or a random price of a random stock somewhere, or anything else, right? So it becomes really interesting. We're still at the very beginning. We're still developing it as we speak, but we're super excited by this feature.
And so the idea is pretty much that any data you're taking from a site that is signed by HTTPS is essentially in itself already verified, and therefore you could just bring it onto the chain without the need for further verification. I mean, you're pretty much allowed, because it's there's a Snark involved, so then anyone could verify it that it was already verified.
Yep, exactly.
Very smart. Awesome. That's very smart. I like that a lot. Although I would say the knock against it, the one knock, and by the way, this isn't, I mean, it's a knock only depending on your philosophy, but here it'd be, there's a centralized person you're trusting. You're trusting Twitter, as opposed to, the promise of the oracles is that it's a decentralized verification, it's a decentralized trust. But at the end of the day, even that, they're just, even in a real oracle, they're just decentralized, verifying that one person, the same idea that one organization said it's true. So, depending on your philosophy, but I do like that. That already is a, overall, I do like your entire mindset where you guys are saying, why try to make so much work? If you look at Bitcoin, it's just algorithmically programmed that let's just give you more and more work to do to make it more secure. And that is great. That makes it secure. But I like how you guys are like, no, let's try to make everyone do the least amount of work possible, because that's efficiency. And I really do like that, even with the Oracle verification. Very cool.
You can say we're kind of lazy, but no, I mean,
no. You guys are doing the hard work, so we could be lazy.
Exactly. We want the rest of the world to be lazy. No, I mean, it's the benefit of, these new up and coming technologies and primitives, right? If zero knowledge proofs, they actually existed, they just weren't this advanced. But if they were, Satoshi could have easily used it in Bitcoin, and maybe we would have not had the challenges that we had. But yeah, like doing this in 2021 allows us to entirely do a new design. And I mean, a lot of smart people in our space do say that zero knowledge proofs are like one of the mega trends and keys to unlock some of the challenges. And we hope, we're applying in the right way.
Mm-hmm. And now, with this capability, and like you said, if you're already programming in that this idea of easy verification, that something has already been verified by something else, does this allow for super easy bridging between blockchains to Mina, using this essentially the same idea of throwing a snark on a already verified thing so that anyone can verify it? And does this allow for easy bridging?
Yeah, it does. You hit the nail on the head.
So essentially going to my real question, is DeFi going to be easy to build upon Mina?
Trick question. Nothing is easy in blockchains, right? I think
right.
That's one of the things we've all learned throughout the years. Like many projects have said, oh yeah, that's just easy, and then 5 years and hasn't been figured out. So I don't want to say it is easy, but the one thing that the Mina's design allows you to do more easily than many others is this kind of like this notion of bridging or trustless bridging comes out of the box, because what the challenge with other bridges, right, is like, okay, to say, okay, how do I trustlessly verify the latest state of Bitcoin on Ethereum, right? Because to do that just purely on an off-chain world in Bitcoin, as you said, requires you to download hundreds of gigabytes of data and try to sync it for a week. And maybe we're just not good engineers. I don't know about you, but even the best ones, Jameson Love, I think, like he runs this great annual audit using various clients to sync a full node. And this year it was 5 hours. I think last year it was, I think 5 hours, 15 minutes or so. Maybe it is getting a bit faster, but not really. So, even those, and he's doing this with like a powerful desktop machine and all. So even those that are great, are taking, a long time. Anyways, so to do that on a chain is a whole other issue. But what Mina brings is, as we said, is this 22 kilobyte thing where you can easily verify on chain. So that comes out of the box. But yes, this notion of like carrying over all the DeFi onto Mina and suddenly it's all, rainbows and unicorns, that's likely not going to be the case, because there's lots of intricacies. But what we're really excited by are some of the unique features and use cases that we can bring, both because it's much easier to be a full node, but also because of these unique benefits of snaps.
So you want to give us an example? I mean, I could already, we've already just spoken about all the pieces, this idea that full node's super easy to verify, and essentially a workaround of oracles that natively allow for verifying off-chain data. So, you guys are there. You guys have thought about this. What's some good examples of just some use cases that are like, for Mina?
Sure. You just said DeFi, so maybe let's go off of that. Okay. As I mentioned somewhere, many of the DeFi use cases are obviously about lending and borrowing, and many of them, if not all, require just over collateralization right now, right? And that is because of how do you manage risk, right? If there's no identity or credit score involved in taking a loan in DeFi land, you gotta put a over collateralized amount of assets such that if the borrower doesn't pay back, you can claw back their assets as a lender. So in the normal world, how many of us are able to take loans without having to put all of our savings in an escrow somewhere is we have a credit score system, right? Where the banking system, or maybe just one bank that we work with, knows our risk level and they price us accordingly. We can't do that, or rather people choose not to do this in Ethereum and other chains, because the minute you put your credit score or your social security number or any sort of identifier on the blockchain, it's public there forever, right? As we said, so you don't want to do that. So how can we do this in Mina is basically to use the two things that we just talked about. One of them is this trustless or universal oracle is what I call it feature. And then the other is so you use that to basically, and we're building a demo on this, but still in progress, to grab your, for example, credit score information from a website that already has it, right? Such as here in the US, there's this website called Credit Karma. So if you already have an account, you can, and it's HTTPS, because every website is these days, you just take that data, trustlessly, and then you do not share your credit score, but you share that your credit score is above a certain number, or it is, it has been within a certain boundary in the last X number of years, right? And then you produce a proof about it, and then just share that proof along with another proof that says this data was for Emre from Credit Karma, and just share that piece of information. So while you're doing this, you're not sharing your credit score, you're not sharing your social security number, you're not sharing your Credit Karma account credentials. You're just sharing that proof, and that proof is sound and it's unforgeable, and thus the lender is able to trust that and say, okay, I trust your credit score, I trust you are who you say you are because the math proves it. And as a result, I don't have to over collateralize you, or I don't have to, get your entire banking history or banking information or your credentials. So that's one use case that we're pretty excited about. There's many others around, like employment verifiability or payment confirmations, and many others. But yeah, the other thing is, as excited as we are about these use cases, our first job these days is to launch the mainnet. So
Yeah.
first got to do that, and then the exciting stuff has got to follow.
Well, and while you're speaking there, an idea popped to me, and you guys can use this as a snark part. Essentially, right now, as vaccines are rolling out throughout the world right now, there is probably going to be a point where countries start to open up their borders again, but on condition that you prove that you had a vaccine or that you had COVID itself. And there are many different blockchains that are trying to verify, provide verification services but they seem way too heavy and way too purpose built. Mina seems like it's pretty easy that at any you don't have to implement a blockchain or have them run the node. I mean, they can just on every immigration office could have on their smartphone, and they verify through the actual HTTPS government website that someone got the vaccine. So I mean that could be an easy use case. Go make some phone calls after this interview. Probably maybe the last time we'll have to say the word snark. You guys also developed Snarky. What is Snarky?
Well, first of all, thanks. It is an idea we definitely thought of.
Oh yeah, nailed it.
Yeah, no. Same with elections. Also,
Mhm.
Isaac even wrote a good post about it. But yeah, all things that we're super excited about. Just likely we won't be able to hopefully do these in time. What I mean with that is
Yeah,
hopefully we're all vaccinated this year and like it's all gone.
yeah,
But
yeah.
these things are still going to be relevant. So we're definitely working on these types of use cases. Yeah, Snarky is it's actually one of the underlying core primitives of Mina. It's a specific programming language that we wrote, but I don't want people to confuse it with like Solidity, because application development is not going to require like a custom language on Mina. We're right now expecting that it's going to be very similar to JavaScript or TypeScript. But the reason we wrote Snarky is because the underlying Mina infrastructure requires a lot of like snarks to be developed. And with these snarks, it's funny, like I have some engineering background, but I'm not an engineer. So I'm not sure if I can still comprehend it after all this time, but one can think of it like electric circuits. So you have to design it and then you have to make sure it works and then you deploy it to somewhere else. So when our engineers are writing all these they're actually called snark circuits. They have to use these specific pieces of tooling, one of which is Snarky, which is again a language that our folks had to design because they're doing such breakthrough stuff. And there's other languages like this specifically for Snark development around various other blockchain projects. But yeah, it is also like a fully open source piece of code or programming language that folks can go out and look for. And yeah, it makes things easier.
Mhm.
Our goal, I guess, is I hope I'm not wrong about this, but our goal is not to make it easy for everyone in the world to develop snarks. We hope people don't have to do it. People can still, develop more basic web applications or simple web applications. But for those that are brave enough to go out and do that, Snarky is a piece of tooling available to make it a bit easier.
Well, speaking to you, it seems like Snarks is the future, and Zernald Fruits, and I'm gonna have to hop into it. Maybe quit my job, start learning how to code, and start making some Snarks. It's interesting. You said you worked for Intel and Coinbase and now O1 Labs. That you kind of gotten to dip your toe into everything. Intel being that more traditional tech company. Coinbase, I'm not sure when you worked there, but I mean, if you were early on, it probably was a small startup, and now it's quite one of the larger companies in crypto, and now O1 Labs. So I wonder how do they really differentiate, especially comparing Intel to the crypto companies? How does it, as a worker, is there a different aim? Is it a different ideology? I mean, I know with Coinbase, there, it's been in the even the mainstream news relatively recently because CEO Brian Armstrong essentially is saying, listen, we're here to work. We want to focus on work. Let's keep politics out of this. you don't really, I mean, at least back in the day, you don't really think so political when you think of Intel. But how was it as a worker and inside working in the traditional tech world versus Coinbase, which is now a slightly larger crypto, versus O1 Labs, which is more versatile and dynamic?
Yeah, I'd say it's quite night and day. Not for any of the, cultural stuff that you mentioned, but more so because, like compared to someone like Intel, Coinbase is still a startup. Intel's like 100,000 people and, one of the older tech companies, so much so that they're even, like become the dinosaur, and people, it's now cool to hate Intel, I guess, at least in circles. So yeah, very different. Let's see, what are some of the key stuff that I can think about? Yeah, like the one thing, so I joined Coinbase when it was about 100 people and left when it was about 800. I think now they're more like 12, 1300. Yeah, like all throughout my years at Coinbase, the one thing that was very motivating and exciting for me, and perhaps a bit different than Intel, was that everyone was super intrinsically like interested at this stuff, right?
Mm-hmm.
Not everyone was a crypto expert that joined the company. In fact, that was one thing that we were trying to do to make sure, like, we don't just hire crypto experts, because we want to get diversified and actually fix some of the cultural issues that the media is just reporting on now. And that was like very cool. It was like being in this school-like environment where everyone is constantly teaching each other something new. I mean, obviously crypto is like that in general, but even like being at one of the more smaller spaces where some of the top minds of the industry are there. It was just always drinking, as they say, from the fire hose. Just constant flood of information. Sometimes it got really tiring, but that piece was just really, really exciting and interesting, and knowing that you're kind of at the heart of this like very exciting space. But maybe the one core thing that I missed maybe about Intel that wasn't there at Coinbase, now that I think is at here at O1 Labs, is as sophisticated and as smart as the engineering and technical talent in Coinbase is, it was still more so building a end user application on top of like these core technologies like Bitcoin, etc. Right? It wasn't like they were doing like breakthroughs in technology themselves, which is something Intel is known for, right? It has a lot of heritage and history about that, and it's something I guess I just got biased into. And it's something that I'm finding here at O1 Labs with Mina, because we're kind of at the cutting edge of this. We're trying to do certain technological breakthroughs and really provide a new platform for other people to go off and do crazy and beautiful things. So maybe, now that I think of it, I hadn't thought of it this way before, actually. This is like something that, that kind of got coded into my DNA early on in my career, and is now something that I'm finding here at this company and project.
Well, I'm glad I could blow your mind and reinvigorate your passion for O1 Labs. But no, I think you do hit on an interesting point here, that it must be very exciting to work in a place that's constantly pushing the boundaries, exploring new territories, and that's something that I kind of want to ask you, because right now you guys are still in testnet phase. You guys are soon to launch mainnet. And we've kind of seen, and you guys seemingly have this amazing idea that really comes with a lot of new advantages, fixes a lot of old problems. It comes with a lot of new advantages, and something that I think doesn't get thought upon enough or spoken about. When Ethereum launched, it's a great idea. It's a great idea. It seemingly breakthrough smart contracts, fixing old problems and enabling new things. But because it was so good, because it was so successful, now it's being choked by its own success. Essentially now, because it was so successful and there's so much value put upon it, it can't scale, and they can't switch over to E2.0 quickly because there's so much value locked upon it. They don't want to mess anything up, and they have to take their time now to really boost their throughput. And so I wonder with you guys, if you guys have thought through this the same. And realized, hey, we have this, potentially amazing product here, amazing blockchain that's so capable. is there scaling limits to it? Have you guys thought through, hey, if this does take off, if this does become, the next blockchain that everyone builds upon, would you guys not be hamstrung by your own success?
Yeah, big question. So there's two ways to answer this. One of them is I guess, the more naive way, which is to say the unique thing about Mina's design is, as we just talked about, it intrinsically, is meant to prevent such issues from happening, right? Because again, like I think Vitalik and others have said this as well, like if you just take Ethereum's code and run it on a private test net, it does like 10,000 TPS and all of the magical stuff that people want it to. The reason it's so slow in real life conditions is because it's like this decentralized network, right? But Mina's entire design is to prevent that, to come up with a design that says, you don't have to trade off constantly between scale and decentralization. So that is all real, but as we think about that scenario where you said, okay, like we're gonna need to provide thousands of TPS, et cetera, what actually happens is that in real life scenarios, one does start hitting other barriers. For example, these are peer-to-peer decentralized networks. The networking layer itself, because they're decentralized, because people are connecting from their home networks and whatnot, right? It's just like this crazy wild, wild west type of place where it just gets really complex and it just doesn't scale as efficiently. So yeah, there's likely going to be many bumps along the way. There's going to be natural limits that we hit in certain stacks of the technology. But the one thing that I keep coming to is, at the end of the day, these are like engineering challenges. Whereas with every other blockchain, there's a fundamental issue right at hand. Is that this, like how do you scale a thing without getting it more centralized? Because ultimately it's about economics, right? Like the more transactions every node needs to process, the costlier it gets. But if it doesn't need to do that, such as the case with Mina, then they become engineering challenges. And this doesn't mean they'll magically go away. This doesn't mean it will be easy, but at least they seem a bit more approachable. So that's how we're thinking of it. It's not going to be, again, just to set expectations, we're not going to suddenly have 10,000 TPS and like 100,000 nodes can run it on day one. It'll take time, but we have a good roadmap and we're excited to accomplish it.
Well, after speaking to you, I'm very excited for Mina as well. Very cool. Thank you so much for giving us, kind of the background and what you guys are working on and your thoughts on it, and giving me a new appreciation for Snarks as well. Now, Emre, those are all the questions I have for you. This is your time to shill. Go shill away. Your favorite project, your favorite TV show, whatever it may be. What are you shilling today?
What am I shilling today? Well, I got to show a bit Mina. As I said, we're right now running our adversarial testnet. We have, I forget at this point, but like I've lost count, but more than 1,400 users on the testnet. All in all, we have more than 2,000 people. So hop on, it's minaprotocol.com. Come join the network and the community. It's we're very happy and proud of one of the healthiest and largest communities in the space. And we're launching our mainnet in a few months. So let's go do that together. And beyond Mina, well, I'm excited to see how that Coinbase IPO goes. I think it's going to bring a lot of transparency, and still, I believe, even the least critical, because everyone loves to be critical about Coinbase. People will be shocked by some metric that they disclose, because it is a great business and it's a great team. So, and I think it's going to be great for the entire industry. It's going to show all the skeptics, wow, there is a lot of usage and a lot of people are interested and a lot of people are paying money for this stuff. And I think that's going to flip some minds, and basically get more and more people to believe in this technology and this industry. So I think that's going to be really a huge boost for the entire space.
Well, I'm looking forward to Coinbase as well as Mina. Mina, where Snagic happens. Emre, thank you so much for taking the time, and really wonderful speaking to you, and for all of our viewers here at Reimagine. I'm Yonah Hochhauser. Thanks for watching.